A substantial amount of the questions that are asked on ACT, SAT, or on some of the other standardized tests regarding equations, degreed equations, has to do with interpreting the equation and relating to what the picture looks like on the graph. We've already noted that when we change the degree of the polynomial, first degree, second degree would be squared, third degree would be cubed in our very first term, we have altered the number of possible times the graph can hit the x-axis. Taking this for example, a third degree or cubic equation where our term, the first term is cubed, has the capacity of hitting the x-axis up to 3 times, 1, 2, 3. We already see that the positive graphs have a tendency to go in a positive direction, the same way as our linear equations did, going from quadrant number 3 through quadrant number 1, and that was a positive slope. But if we turned that around, we could give it a negative slope. And in that case, what we needed to do is negate the very first term of that polynomial. And that's exactly what happens when you negate the coefficient of the highest degree of the equation that you're working with. Then the graph turns down. Here our parabola has an upward swing, has a downward graph for the parabola. Here we've got a cubic that starts here and ends upward. So it starts down and goes upward, and it reverses it when we have a negative coefficient. And you can see what happens to the rest of the graphs. Our W turns into an M, and to the 5th degree we have a starting high and undulating, so it is ending pointed downward. I only took these polynomials to the 5th degree, but of course they can go to infinity. But the same rule happens. Let's see what actually happens to the picture of the parabola when we work with a quadratic equation. If we take this one right here, 4x squared plus 2x plus 6.